So just to recap, to show us where we are now, I'll bring up March 2nd really quickly. We talked about the help documents in last week's lecture. Talked about all the different symbology. I said a lot of this will be covered on the quiz. And we talked about the use of interfaces in ArcObjects programming, or the IMAP, iDocument, and so on. That's where we have been. We talked a little about GUIDs, and at the very end of the March 2nd lecture, we started getting into data frames. Data frames are IMAP, the containers in ArcGIS that actually house GIS data. And we actually did a little bit of our first GIS code where we worked with the MXD document object, IMX document interface, which is your MXD. We worked with IMAP. As I mentioned a minute ago, IMAP is an interface to map, which is a data frame. And we looked at a couple properties like focus map that return the active data frame. So that's kind of puts in perspective where we were when we last met a week ago. And we stopped right here where we had written some code to use a for loop like we learned back in February to loop through maps and post their name for an MXD with multiple data frames in it. So that is a quick review of how we got here. And now we'll jump in. I'm curious if this... Oh, okay. That's what the slowness was. It was all the net drives. So here's some code, and we'll continue by talking about snippets of code related to data frames and maps. When I say snippet, often, in Visual Studio, that's the actual definition. A snippet is a small, self-contained piece of code that performs a small function. For example, here's a snippet of code that redraws the map. I think I touched on this informally last week, but here formally it indicates, when you're working in ArcMap, you're used to it, it just redraws for you. And I open up ArcMap, turn on my layers. Okay, oh good, here's my states. I'll zoom in. And it's that easy, the map redraws. In ArcObjects, you have to tell it to do that. It doesn't automatically know to redraw when you manipulate the map. So this slide that we're currently discussing describes that for us. And the method to redraw the map is refresh, and it requires 0 arguments. It's a method that requires the blank parentheses because there's no argument. And it's on the class map. If you think about it, you're asking the data frame to redraw. But it's not in the I'm not going to go back to the other slides, but at the end of last week, we used the interface IMAP to redraw the map. Now, the refresh method is on a different interface called iActiveView. So when we want to redraw the map, we have to define our C# variable using the interface iActiveView, and we're setting it to the document's focus map. So if I just started setting up a Visual Studio project for you. I'll call it March 9th. Everything's slow today. There we go. So if you call it to add a button and add in, you right click, add, new item, ArcGIS, desktop add-ins, add-in component, and I'll call it redraw button. Pick any symbol. And here's my redraw button, C#. Remember, often the first thing we have to do is the using statement to link to the libraries or namespaces that by default are set up in a Visual Basic add-in project. I think I might only need ArcMap UI for this. We'll see in a second. And as we get, as I mentioned last week, as we get and build more involved code, we'll be adding a lot more references. You saw that a little bit in some of the demos already than just this. We're starting out very simple tonight. Might be in Carto. Add ArcGIS reference. Yes, right. ArcGIS Carto is one that's very often added. Carto has a lot of classes related to featured layers and objects and cartography. That's Carto. I might not be right though. Nope, I am. So now notice iActiveView showed up. It's in esri.arcgis.carto. So I'm going to declare a variable using iActiveView. There's a couple things I want to point out here. So remember, we can get to the current map document with this top level there, object arcmap.document. And as I showed right at the end last Monday, focus map is a property of the document that returns the active data frame. But notice it's not happy. This returns the active data frame, but as the default interface of IMAP, whereas I mentioned a moment ago we need to use iActiveView. So when that happens, I want to show you the error so you can debug that. What it says, cannot implicitly convert type IMAP to iActiveView. An explicit conversion exists. Are you missing a cast? Remember, we talked about casts last week when we talked about interfaces. So this returns the wrong interface. So I need to cast it to iActiveView. And I had shown that in last week's lecture. The simplest way to do that is to put iActiveView in parentheses before this. Keep in mind this has to be a valid cast. If I try to cast it, say to a line symbol or something, I'll get an error. But IMAP to iActiveView is a valid cast, so this is going to work. We talked a lot last week about how certain classes only work with certain interfaces, and interfaces can only be cast with certain interfaces. That would come into play here, if I had chosen the incorrect cast. Any questions? That make sense? And once I did cast to iActiveView, the refresh method is on the iActiveView interface, and I can just redraw the map. So I can save. I'll go to Build, Solution to see if I have any errors. I don't think I will. Build succeeded is in the lower left. That might be hard to see for some in back. So I'm going to click Start. This doesn't take forever every time. If you call Start, opens up ArcGIS when it's an add-in. We'll test out this very simple tool. So here's my application, or my MXD. In order to add your tool, you go to customize mode, commands. I think I said GEO555 tools when I was starting this a moment ago. We'll see in a second. There it is, redraw button. Drag it out here. It's really taking that long. Let me do this. It's redrawing it so quickly. I was afraid of that. Computers have gotten too good. It's redrawing it so fast you can't tell. But trust me, that makes the map redraw. So there's our first snippet from this evening. We'll explore, I think I hinted this was coming last week. We'll explore another method for updating the table of contents later on. This just redraws, oops. This just redraws the map. But another thing that you take for granted as a desktop ArcMap user, if you change a legend, like you'll do for Lab 3, let's say you open up the Michigan and you change it from orange to blue, you have to redraw the legend too. That's a separate step in addition to this, and we'll cover that in a bit. Any questions? So we actually sort of discussed this as well at the end of last session. But as I mentioned then, and we see now, data frames are the portal by which we can get to the map layers. Map layers in ArcGIS, as you know, if you've used ArcMap enough, are contained within a data frame. So in the screenshot here I have 5 map layers, 5 GIS data sets within the data frame that I'm calling new data frame 2. One other thing, so we kind of talked about that at the end of last week. So I had that map, I won't bring it up again, I just showed it to you with the counties and states in it. One other thing I didn't show is that there's a property on the MX document. Now this is interesting, it's easy to forget, it's not on the data frame, it's on the MX document. There's a property that returns the selected layer. By the selected layer, I mean the one that is highlighted in blue. The reason that it's on the document is you can only have one selected layer in the entire map document. So even if you have multiple data frames, I'll prove this in a minute, only one layer can be selected. And you can get your layer with this property selected layer on the MX document. So if you look here, where do I have some data? Oh, from my summer class. This laptop could use some organization. Okay, so I have the same. Even though I have, so right now the selected layer property would return that layer. But if I click, and a user selects a layer by just single clicking their left mouse on the title. It's a single click event. And notice even though I'm in a different data frame, the selected layer changed. I'm not going to I guess I'm spending time on it. I'm not going to spend too much time because there may not be any selected layer. Sometimes this is useful, but when you first open the map, there's none, so you can't assume there is one. So that could be problematic in code. But I want to make you aware that this is a way that you can get to map layers. You could always have a program where you ask the user to select a layer in that way. If there's no selected layer, which is certainly possible as I just mentioned, the property returns a null, a C# null. So if you use selected layer, you should combine it, put it within a try catch block or an if statement to test for selected layer being null before you try to use it, and then warn the user, if it is null, that they haven't properly selected a layer. As shown here. Forgot I put a slide into that. So in this snippet of code, I'm getting selected layer, and I'm first, before doing anything, testing to see if the selected layer is equal to a null. In that case, I'm message boxing the user, telling them that they never selected a layer. I didn't add it here, but you might want a return statement here. So I'm assuming that that would depend on what your code does after this. If your code after this point depends on a selected layer to continue, you would want to exit, because the condition, if you think about it, the conditions haven't been met. So say you do require a selected layer, you would give them the warning and then have the return statement within the loop. Where the return statement just stops your program from running. Are there any questions? Another way to get map layers is through the index. Individual layers can be referenced through a map layer index on each data frame via the getLayer method in ArcMap. This is a little different than, I think it's a C# thing. The property, where is that? Here it is. So we talked about this earlier tonight. We use the focus map property to get a map, a variable that's the map using the IMap interface. So this, my map represents the active data frame, and I know it's the active one because the property is focus map. On that, I can retrieve specific layers with the property lowercase get underscore layer, capital L. Remember, C# is case sensitive, so that's important. And then an index starting with 0. If this were a VB class, it's actually just layer. You don't have the get underscore if it's VB.net. But this is C#.net, so it's the actual property is as pictured here. So I'm getting layer number 3. You might be tempted to think that that's the Ontario municipalities layer, but it's not. It's actually this one, Orleans municipalities, because they're numbered 0, 1, 2, 3. So the 3 is actually the 4th layer in the list, from the top down. Does that make sense? Good. This will be a source of confusion throughout the class. I apologize, there's not much I can do about it, because ESRI tends to use indexes that start with 0, but often Microsoft will use indexes that start with 1. So you unfortunately kind of have to, you'll see, not just layers, you'll have get field, get array, there's all sorts of objects and classes in programming where you're retrieving an item from a list. And sometimes it'll start with 1, sometimes it'll start with 0. And unfortunately that's something that you'll have to learn to remember or at least look up over time. But a general rule of thumb is ESRI seems to like the ones that start with 0. Microsoft likes ones that start with 1 in many cases. But as I put here, getLayer is a 0-based index. When you start working on Lab 2, this will become very handy. So So if I go into my March 9th example, I'll add another, oh, it's running. Add new item. I'll call it layers button March 9th. For lack of a better. Here's my new button. I'll copy and paste the using statements from the ones we just started. So I'll start out my code in onClick. Say let's get to the data frame. And that says you'll see these two lines starting your code over and over and over. So just to mention, and because it's so important, I'll repeat myself a couple times. I apologize, but I think it's worth just drilling the point home. So here we're first getting through arcmap.document the current map document that you're in, the MXD, and then the second line retrieves into IMAP whatever the active data frame is. So that's often our jumping off point. So if we want to get the second layer, I could do that with another thing. I'll review this for the message box that's in system.windows.forms namespace. So I need to right click, add reference. That's not an ArcGIS reference. That's a general Microsoft library. So it's just add reference. System.windows.forms. Check it. I don't need to browse. And I'll put a using statement in for that. Okay, and you see an error. I want to talk about that next. It's not, looks like this makes sense. It's not too happy with me, and we'll see why. If I hover over, I mean, from what I described you, this looks right. And we're getting the second layer of the data frame. But it's another cast error. I mentioned this because this will happen a lot. You cannot implicitly convert type I layer to I feature layer. The map just returns the more parent class or interface I layer. Remember we talked about the parent-child relationships and polymorphism last week? That's what's happening here. It's returning the generic I layer, but I'm trying to assign it to I feature layer. So it's a cast problem. Now I can make this error go away very quickly, but we should talk about this further. So okay, cast that to I feature layer. It's happy. I'm taking the layer, casting to I feature layer. Looks like it'll work. We're good, right? And in fact, I'll do this demo in a second, and it will work because that's a feature layer. Can you think of where? This code though could be problematic. What if the second layer was a grid or digital photography, or something that would be an I raster layer? What if it was a CAD layer? In that case, the code would cause an error. So what I'm doing is I'm assuming that it's a feature layer. And in this example, that's correct, what they say about assuming. So you might want to, in this case, test. We talked about the is keyword weeks ago. First test to see if that layer is a feature layer before you try and cast it, because there's a chance that it's not. So in other words, this will work if the second layer is a feature layer, but it won't work if it's a raster layer, some other kind of layer. That wasn't too bad that time. So I'll open up my document. Well, I have too many open. ArcGIS likes to lock files. This is my layers menu, or my layers button. Second layer is US counties. Is there any other questions? Another example of combining every layer, we'll tie this into a for loop next. If I can find, oops, I don't want that one. So instead of getting just one layer, let's loop through and make a message box string for all the layers. So I will create a blank string called my layer list. Remember we talked about for loops back in February, so this is tying in and reviewing. Remember, a for loop is a generic C# function. This isn't specific to Arc objects, and I hate when it does that. more layers. So to review the for loop, there's three elements in a for loop separated by semicolons in C#. The first is the declaration of a counter, an index variable, which is an integer. So I've declared an integer variable named x that will start out as 0. I then indicate that indicates when the for loop starts, x will be equal to 0 inside the for loop. When will the for loop stop is the next item. The for loop will, not exactly. When will the for loop continue? The for loop will continue as long as x is less than this value. Now a data frame, which is pmap here, has a property called layer count on IMAP, which, as you might guess from the property, is how many layers are in the map. So the for loop will run as long as x is less than how many layers are in the map. You might see where I'm going with this. And then every time we go through the for loop, x++ means we increase x by 1. So it'll go 0, 1, 2, 3, 4, however many times, as long as it's less than the count of layers. So in each case, I can say message box show pmap get layer x. Or it's get underscore because it's C#. Instead of a number, so the first time it's going to get layer 0, next time it's going to get layer 1. Remember, I mentioned this last week. We're actually we're getting the layer, but we want to display its name. So I need to put the name prompt. It's a very easy thing to forget. You'll make that mistake a million times if you're like me. Think of the analogy, you are you, but your name is how people refer to you. So we want to post on the message box the name of the layer, not the actual layer. And I think that's how I did it on the actually I want to do this a little different. And it's actually called it my layer list. That's somewhat deceiving because it's not a list object. So here, every time actually, let me think about this a second. I want to do that a different way. I only want the message box to come up once. So I'm not going to do it this way. So I'm going in circles a little bit. So look what I've done here. During the loop, I am adding to the string my layer list, which starts out blank. The first time it will set itself to itself plus a carriage return plus the name of layer number 1, number 0. Then the next time it'll take that which already has the layer number 0, add a carriage return, and then put the next layer with a key. The /r/n is carriage return. Then once we're done with the loop, then I put the message box outside the loop so the message box only shows up once. So let's see what that does. So now notice that string has been added, the for loop went through and added each layer name plus that caret return 3 times. Next thing we're going to talk about is enumerations. Any questions before we forge forward? It's not. It says it's first exposure. It's not really the first exposure. We talked about enumerations when we looked at those object model diagrams very briefly. If you remember, you may remember I mentioned it's a special type of variable that contains a list of constants. So enumerations are used when there's too many enumerations, I guess, are too many consonants. The enumeration is used when there's a set number of different possibilities in it for an argument. For example, let's say you're creating a new vector shapefile. Well, there's really 3 choices. I'm simplifying a little, but there's only when you're creating a shapefile, what is the shapefile? It's a point, line, or a polygon. It's not really, the argument's not really open to many different things. There's a set number of choices that you choose from. That's when Ezra uses an enumeration. Or when you're selecting an attribute. It's a new selection, a select from, adding to selection, or removing selection. That's an example where that is enumeration, where you would choose one of those 4 things. Another way to use enumerations, okay, so this is a little different. That's one definition of enumerations. But another type of enumeration is also when we loop, is like a loop. I'm mixing things a little. And this is our first exposure to the second way in which we use enumerations. In an enumeration, and we will do plenty of these examples later in the class. I'm not sure I'll stop and do the whole demo of this. In this type of enumeration, we don't know, that's why I don't like them if I can avoid it. When we start, we're enumerating through a list of things. When we start doing that, we don't know how many objects there are. Like with layer count, we can tell from the beginning, okay, there's 3 layers. With an enumeration list object like this, and often this does happen with cursors, we'll talk more about cursors after spring break, you don't know when you start how many times you don't know how many features you're going to get back from the beginning. So in this example, we're using a property on the map called getLayers. Not getLayer, but getLayers, plural. You can issue, here's what we could use, not to confuse this, I know, on the other kind of enumeration that indicate a specific type of layer. Or we can say null to say give me all layers in the map, and then usually issue true for some of that recursive. That returns a variable that with an interface called IENumLayer. The IENumLayer has within it a list of the layers in the map, but we don't know how many. There's no layer count. So rather than working with an index, you have a pointer that points to the first layer, and you step through with the next command. So we have our IENumLayer. We start out with the method reset. Reset kind of brings it to the top. So that ensures that we're looking at the very first layer in IENumLayer. And then you just work with that layer to get each individual layer, and saying I layer, my layer equals to the variable .next. Next gives you that next layer in the list. There's no index. So in this code snippet, this is similar to what I just typed. We've defined the enumeration with getLayers, plural. We've reset. We're getting the first layer with next. And this essentially, this code does the same thing that we just looked at. But instead, we can't use a for loop because we don't know. With a for loop, we need to know how many times it's going to run. We don't know that, so we can't use a for loop in this case. So we're adding to the string just like we did a moment ago. But instead, we use a while loop. And then we say while p layer is not equal to null. So with an enumeration, we keep saying next, next, next. And as long as there is a next layer, it'll return that layer. When you get to the end of the list and there's no more layers to return, it'll send you back a null. So that's when you exit the while loop. As long as p layer is not null, there's always another layer. You know you're not at the end of the list yet. When you get to the end of the list, this will be null, and you can skip out. Does that make sense? And remember, it's very important in a while loop to make sure you put a next statement. This is something else I've done a gazillion times. If you don't have a next statement within it, you'll get an infinite loop. Because there's no next, it'll never go to the next thing, it'll never stop running until you close the program forcefully. So here, instead of the index, I go to the next layer with this next method. Eventually, when we get to the last one, p layer will return null, and then we'll end the while loop. Any questions? So it's a different way of getting the same thing. If you might have, specifically when we're talking about getting layers, you may have noted the example we did a few minutes ago is a little simpler than this way. So I would use the former method in this case. But something specifically with something called feature cursors. Feature cursors I use for attribute queries. We will use this method. So I won't go into this too much other than this discussion, and we'll talk a lot about these enumerations, I said probably shortly after spring break. We get into the attribute queries and search cursors. Any other questions? It's early yet. We're going to talk further then about setting properties and reading properties on layers. That's the next topic this evening. As I wrote here, you can use Arc objects to read and set properties of layers. And to review from last week, all specific types of layers inherit from iLayer. So we work with iFeature layer a lot in the course, but there's iRaster layer, there's many other types of layers out there. They all can use these basic iLayer properties. As you can see here, there are some basic properties on iLayer, such as its scale. You can control the scale at which it's displayed, the layer name, tooltip text, whether it's visible, and so on. This slide also shows us that we can cast to another interface called iGeoDataset. iGeoDataset is in a different library that I don't think we've used yet. It's in the ESRIDA ArcGIS.GeoDatabase library. The layer libraries are in this Cardo library I've already talked about and we've already used this evening. So to use iGeoDataset, you have to add a using reference to this geodatabase namespace. We use iGeoDataset for two things, really. To get the extent of the layer. Extent, that might be hard to read. Extent returns an I envelope. The extent is the smallest rectangle that would fit the object. So if this is, Pennsylvania. So say the object is the state of Pennsylvania. Its extent, somebody use ruler. The extent is this rectangle. the smallest rectangle. So extents are used for zooming too. Like if you right-click zoom to layer, zoom to selected feature, use an extent. And the extent uses envelope, which is another thing we'll talk about much more after break. This is our first introduction to that here. Envelope is in, or extent though is in the GEO dataset interface. The other property on GEO dataset that comes in handy is the spatial reference. You can use this to get a layer's map projection. It returns spatial reference, which I think we do talk about using that right near the end of the course. How you can use this to figure out what map projection the data is projected into. So in this simple example, maybe I will run this. And then this is, we get into this sooner than I remembered. This is that second refresh that I talked about at the beginning tonight. So in this simple example, we're getting the selected layer, and we're changing its name to a different layer name. So we're modifying the layer's name. It's a read-write property, and if you remember, is that on there? It is. When we talked about the map or the diagrams, a barbell with two boxes means that the properties read and write. So when I see that on name, I know I can also use code to get the name of a layer, but I can also use my code to change the name of the layer. That's a change in the table of contents, if you think about it. So this is the first time that second update comes into play that I mentioned at the start tonight. That's a method called update contents on IMAP, so on the data frame. So anytime you make any change to anything in the legend, I was thinking of it in reference to Lab 3 when you're changing symbols, but here we're actually making a legend change too. We need to update contents. So here, and just another screen example, I've used this to change the layer's minimum and maximum scale at which it draws. So here, let's get the first layer. See, I'm making assumptions again. I'm assuming, let's just make it I layer. I'm assuming the first layer in the map is the Canadian counties data set. I know it is, but remember that's an assumption. So I can use the code to change the name of the layer in the table of contents. And that's actually on the, I think I misspoke a moment ago, it's on the IMX document, the update contents. So if I run this now, and if I run my tool, it's already there. Notice a couple new things. Notice it changed the layer name, like the code indicated. And it's hard to visualize it, but update contents worked because if I didn't put update contents in there, you wouldn't have seen the layer name change. Are there any questions? We'll take this one step further, and I do want to add this to the demo as well. Remember I talked about iGeo dataset a few minutes ago. One of the properties on iGeo dataset is extend on the layers. You get a layers extend. iActiveView on a map also has a layer property called extend. So I can use this code to zoom the map to a specific layer. So when you right-click a layer and say zoom to layer, this is what it's doing behind the scenes. Now you'll see how to code that yourself. So I'm getting the layer, but instead of iLayer, I'm casting it to iGeo dataset. I'll do this in a second. I'm getting ActiveView, and I'm setting the ActiveView's extent to that layer's extent, and then redrawing the map. So I'll do a cast for ActiveView and for Geo dataset to get the extent. I'll call the variable PAV. So I already have a PMap. So if I scroll up, remember we already have the focus map as PMap using the IMAP interface. I'll just now cast that PMap to PAV using the iActiveView interface. If you remember to review our initial discussion of casts, we now, and casts and how they relate to object-oriented programming, we have two different variables referencing the same object but using two different interfaces. And my weird analogies I like to use is I could refer to you by your full name. I could say, you know, congratulations, Willard, or I could say congratulations, person number 326485, or whatever your UB number is. Really? I'm gonna go play the lottery. But whether I say good job 326415 or Willard, I'm referencing the same object. So the same thing here. Whether I use PMap, sorry to refer to as an object. Whether I'm using PMap or AV, I'm also referring to the same object, that data frame. Oh, and I also, to continue with this exercise, as the slide indicated, and I had forgotten, we need to add the Geo database library. So right-click, add ArcGIS reference, ESRI ArcGIS Geo database, finish. I'm going to add a using statement. So, same spiel applies. Just like I was talking about now. Now I have the variable can counties and PGDS both reference that object that represents the Canadian counties layer, but one using the iLayer interface originally, and now using iGeo dataset. And because I've changed the map, don't forget the refresh command. So now let's take a look at that. Uh-oh. I'm glad this came up. Sometimes you explicitly or not, you're implicitly referencing something in another class, even though you haven't declared a variable. I've just said set the layer extent equal to the map. Set the map extent equal to layer extent, and as I mentioned before, that involves iEnvelope, even though I didn't declare an iEnvelope variable. But iEnvelope is in a different namespace, esri.arcgis.geometry. So I need to add that reference. Often you'll kind of implicitly use a class in another namespace. I don't say by accident, but without realizing it. Luckily, when that happens, the error is pretty useful. It pretty much tells you what you need to do here. So I'm going to go in and add a reference to the geometry namespace that ESRI provides. Now I'm going to go to build. Build started, build succeeded. That solved the problem. So I'll click run. And now when I click my tool, notice it did exactly what I asked it. It zoomed the map to fit Canada. It goes a little off the screen here, but you get the point. Are there any questions to this point? We'll go a couple more slides in and take a break. It's 8:15, so we'll keep moving. As I suspected, we're doing well. And as I already mentioned this, but the slide also reiterates, that we're implicitly using that envelope class in this statement. That's why I had to add that geometry reference. So some review, a quick review of abstract and co-class classes. And we talked about this just last week. And as I think this is just a copy of a slide from last week. Those classes are what we call co-classes. And on the object model diagram, they're gray and they kind of have a 3D look to them here. A co-class can be created from another object. You can also create a brand new object of the type co-class with a new keyword. We've kind of seen a little bit of that to date. We haven't done that much. We will more later. But when you have a co-class, the programmer has the ability to instantiate out of thin air a brand new, wave a magic wand, so to speak, create a new object of that class out of nothing using this keyword called new, which we'll talk about shortly. Most classes are co-classes. There are a lot of classes where you can create a new object with this new keyword. And as I mentioned, they're shaded in on the object model diagram. And then we also talked about abstract classes, whose titles are parentheses, being a type of class that usually is a parent that co-classes inherit from. Abstract classes don't have objects belonging to their own class, but rather the objects belong to the co-class beneath them. The example I used last week was mammal. You don't have an animal in nature that's just, oh, what is that? Oh, it's just a mammal. I mean, it's a person, it's an elephant. I think an elephant's a mammal. it's a dog or a cat or fox or so on. Every instantiation of something that is a mammal belongs to a subclass, if that helps explain it. That's a co-class. Foxes, new mammals can be created, but you don't have an object in nature that's just some generic mammal. All the objects belong to the classes further down on the hierarchy chart, if that helps review the abstract versus co-class. So why am I bringing this up now? To review two interfaces that we'll use quite often, although the bottom one more often. In a specific example of this abstract co-class relationship, I've already sort of mentioned this earlier tonight. Anyway, you have a co-class feature layer and an abstract class layer. You don't ever have an object in a data frame that's just a layer. It's a feature layer if it's a shapefile. It's a raster layer, say if it's a grid. If it's AutoCAD data, it's a CAD layer, etc. So in this specific example, iLayer and layer is the abstract class. Feature layer with its default interface iFeature layer is a co-class. So you actually can create a brand new feature layer out of scratch using that new keyword. And we'll get right into that right away. So in this example, this is the same. I told you that we'd start out with that often. But now, here's some new stuff here. Feature layer is a co-class. So on this third line, I am creating a brand new feature layer out of scratch using the new keyword. The new is all lowercase. I think I might have PowerPoint capitalized it a couple slides ago, and it shouldn't have. So here I'm declaring a feature. I'm declaring a variable with iFeature layer just like we already have. But instead of setting it to something using getLayer, I'm using the keyword new. And I'm saying feature layer, and this is a C# thing. You wouldn't see the class appended in VB.NET. Equals new feature layer class. So this line essentially says, give me a new object of the type feature layer class using the iFeature layer interface. So I have instantiated a brand new object out of thin air that is a feature layer. And then I can do the same things with it that we've been doing already. I can give it a name. And in this example, I've actually added it to my map. And then I'm updating the table of contents. So let's go through that. We'll take a break. That's a good breaking point. So after we go through this, then we'll take our break. I'll add that as a new button. We'll call it March 9th adding layer. I'm going to go in and grab my using statements. And I think I should go in and grab these initial two lines, because we'll repeat those in the next code. and I need the parentheses. So, as I typed in the slide, we're creating a brand new feature layer class object, the new keyword, and we're using that interface. We'll give it a name. We would say visible. So we'll add our new layer to the map, and I'll run this. You might think we're all done, but this is only the beginning, and maybe you can think why. We'll see in just a second. Oh. If I hit build, there are happening in. I'm implicitly referencing the ESRI ArcGIS display. Add ArcGIS reference display. I'm not sure why I am. The build errors go away. I go to customize commands. March 9th, adding layer. It did it. Look, it added a new layer. It created a brand new layer out of scratch. Gave the name, made it visible, added it. You might notice in media problem. Got the red exclamation point. I never assigned any data to it. It's just a feature layer without point. It doesn't actually point to any GIS data. That will tie into the next topic, workspaces and feature classes, that we'll start right after our short break. We'll start up back up in 5 to 10. Usually ends up being 10 to 15, but that's okay.